in the series of webinars by 4C. We're going to have about 80 webinars over the coming 4 months leading up to the conference. Very much appreciate Randy Bartley being the first to kick it off with BAIR. Randy lives in Southlake, Texas. His office is about less than a mile from my office. And I've got a lot of customers over the years that use Randy's company services, use BAIR services, and they've all been very happy with the services provided. So, we're really proud to be able to associate with Randy Bartley and the BAIR team. And with that, I'll kick it off, hand it over to Randy.
Yeah, thank you, Steve. Thank you for allowing me to be the guinea pig here. I hope that we don't turn off the entire audience to what you guys are trying to kick off here with your webinar series. Very, very thankful for the association with 4C and the opportunity that we've had to be a part of the conferences. We've been there the last several years, and just a lot of content that we've been able to pick up on and learn from, and also just being able to present there as well, and presenting in this format. Just love the idea of an ongoing conversation about test methods and regulations. And so, yeah, I've got quite a bit of content on the slides. I am not going to read everything verbatim. That's not what people pay for or sign up for when they do this. I do have a mock stack behind me. We'll get to that here in a minute. But Bailey, I guess I just need to share my screen for the PowerPoint to kick off, correct?
Yes, please.
Sir.
Okay, so you guys should see the PowerPoint at this time, correct?
Correct, we do.
Okay, great. So in this session, we're going to cover some engine testing method updates. Some of them are a little bit older, and some of them are yet to be in effect. But anyhow, we'll associate the applicable stack test types that are associated with these rule changes. We'll talk about the 2014 revocation of the alt methods 061 and 087 for single point stack testing, and the requirement to do stratification checks on exhaust stacks. We'll talk about the 2016 EPA updates to the FAQ section of reference method 19, where you're allowed to use fuel rates to calculate your exhaust flow. We'll talk about some probe selection and sample point location, stack configuration issues that tie into what type of probe you can use in certain situations. And then we'll switch gears quickly to talk about using the ASTM D6348 method. This is associated with using FTIR analyzers, which is the primary analyzer used for engine testing these days. There's a little bit of a gap in the Quad J regulations and how it reads, but the intent is otherwise, and so we'll go over that briefly, and then just upcoming changes to how reference method 2 and reference method 7E are used with engine testing that will go into effect in about a month. So that being said, the types of tests that we are covering would be your 40 CFR Subpart Quad J, Subpart Quad Z, Quad I for diesel engines, Quad K for turbines. You can have state applicability under 40 CFR 60.8 for initial performance test. And then you have specific state regulations like the Texas Administrative Code 30, Chapter 117 requirements, or perhaps 106.512 testing for permit by rule engines in the state of Texas. Louisiana and New Mexico have have their own requirements, Arkansas as well, and several other states. But that's essentially what we're going to cover here. So getting into the alternate methods, 061 and 087 for single point and waiver of stratification tests. So it was generally thought that stratification doesn't occur within engine exhaust, specifically in smaller stacks. It was thought that the exhaust flow or the exhaust concentration would be well mixed after a muffler or a catalyst housing. Stacks that are less than 4 inches are exempt from any sort of stratification test per the test methods. And it was also thought that emissions from engines are going to be too temporarily variable to get a good stratification test completed. This certainly applies with rich burn engines where you've got your air-fuel ratio controller, moving your NOx and your CO levels up and down as it's trying to, stay within its allowed limits. And so there was some planning from the EPA to revise Quad J and Quad Z to allow single point tests. This did go into effect for a couple of years, but was reverted in 2014. In Alaska, someone from the Measurement Technology Group in Alaska said, hey, we believe that specifically with stacks on engines, compressor engines, subject to Quad J regulations, ultimately subject to Quad Z regulations, they believe that in stacks larger than 12 inches in diameter that you could have stratification occurring. So those alternate methods to do the single point testing and not have to do the stratification test were revoked back in 2014. What I've done here is provided the actual copy of the letter across 3 screens here. Again, not going to go in and read all of this, but hope that you guys will refer back to it at your convenience and read this letter and to have a better understanding of what needs to be taking place out in the field. So we'll define where we're supposed to be sampling from on a stack and what method 1 says regarding flow disturbances, and then how you're supposed to do your stratification checks on an exhaust stack, and then we'll talk about the differences of using method 2, where you directly measure exhaust flow versus measuring your fuel rates to calculate your exhaust flow. So this screen is a little bit blurry, and I apologize about that. When you get a copy of this, you should be able to read it a little bit better. But stacks are supposed to be designed according to method 1 to where you've got test ports located in a position to where you meet certain flow disturbance criteria. The flow disturbance criteria of method 1 says that you would be your sampling location would be 2 stack diameters upstream of a disturbance, and so the open end of the stack is a disturbance, and then moving further upstream, you have any expansion or reduction in pipe sizes, or with many exhaust engines, there's a curve coming up out of the muffler where the exhaust points straight into the air. That bend is considered a flow disturbance. So method 1 says you want to be 2 stack diameters from the downstream disturbance and 8 stack diameters from an upstream disturbance. Alternatively, they do allow for a half stack diameter from a downstream disturbance and 2 stack diameters from an upstream disturbance. Most engine exhausts are set up to meet that half and 2 stack flow disturbance criteria. And so that's where the test ports are welded on to the engines. That's where we can typically get access for our sampling. But again, we'll get into some situations and issues where stacks have not been set up the correct way here in just a little bit. But anyhow, this is a general idea of where we should be sampling from. So the waiver of the stratification check pointed us back to method 7E, specifically section 8.1.2, determination of stratification. And what method 7E says is you need to sample from 3 points on a line within your stack, located at 16.7, 50%, and 83.3% of your stack diameter. You need to sample at each of those points for at least 2 times the response time of your sampling system. So these are parameters that are determined on a daily basis as you do your pre-test calibrations, determining your sample response time. And so, so method 7E section 812 says you sample at those 3 points for at least 2 times the response time, and then you take those 3 points, the average of the mean, and if at each of those points you are less than 5% of the mean, or plus or minus 5 ppm, 0.5 ppm, whichever is less restrictive, then your stack is considered unstratified, and you can collect samples from a single point that most closely matches that mean. If you are greater than 5% but less than 10%, or 1 ppm, then the gas stream is considered minimally stratified, and you're required to take samples at 3 points within the stack. And this can be accomplished in 2 ways. For a 60-minute test run, you could sample for 20 minutes at your 16.7% stack diameter, 50% stack diameter, and 83.3% stack diameter. Or you can use what's commonly called a 3-point long line or a rake probe, which is, and we'll show some examples of a rake probe here in a bit, and when it's appropriate to use it, when it's inappropriate to use it. But if you do this stratification check and you find that you are greater than 10% of the mean, then your stack is considered stratified. And what the method would tell you is you would have to go back to method 1 and sample at all of your traverse points. And so we'll cover traverse points here in just a second, and how you can divide a stack into equal areas to assure that you are getting a representative sample from each area in the stack. So here's an example of a stratification test being done where sample point 1, sample point 2, and sample point 3 done at 16.7, 50%, and 83.3% of the stack diameter. This stack was 12 inches. So we positioned a probe at 2 inches from the far wall, right in the middle of the stack, and then 2 inches from the near wall. Got our sampling time and, sampled for 2 times the response time, and found out what our average concentration was. And then at each point, we would need to be within 5% of that average. So the average concentration was roughly 140 ppm. To be within 5%, we had to be just under 7 ppm at each point, no further from that point. So we found this stack to be unstratified, and we're able to position our sampling probe at the centroid area of the stack to get the test runs done. So this figure shows you how you would divide up a round stack and a rectangular stack into equal areas to get your points where you would do your sampling from if you don't meet the stratification requirements, or if you're going to measure your exhaust flow. These are all the points where you would position your pitot to get your differential pressure within the stack, so that you can take that data and get your exhaust flow and take your ppm measurements and turn those into mass emission rates, pounds per hour, tons per year, or grams per brake horsepower hour. So getting into the differences here between how to convert into mass emission rates, you have 2 options. You have EPA reference method 2, and you have EPA reference method 19. Method 2 is where you're going to use a pitot to actually measure the differential pressure in the stack, and it does require an appropriate stack design where you have sampling ports that are located in those regions that meet the flow disturbance criteria. If you're going to use method 19, this is based on measuring your fuel rates from the engine or the source. And it does require a dedicated fuel meter, and we'll get into the specific which that the FAQ section addresses in method 19. And this is something that was put into effect back in 2016, and yet we still see a tremendous lag in the industry, not only on the stack design side, but also how operators try to overcome the obstacles here, and how stack testing companies approach this. And so we'll talk about that here in just a second. So method 19 in the FAQ section, which I've got a link here at the bottom of this screen that you can access, directly access the FAQ section. What they came back and clarified was that if you're going to use method 19, you have to have a dedicated fuel meter per engine or per source that you are going to be testing on. A lot of compressor stations or gas facilities may have a master fuel meter where they know the total fuel usage for all of their sources at that station or that gas plant, but they can't divide it up per source. And so this was something that was changed. Another commonly used method under method 19, or practice under method 19, was to look at the engine manufacturer's specs and interpolate, okay, if we're at a 75% load or 90% load or in between a certain range, we can estimate that the brake specific fuel consumption on that engine is X. And using X, we can go ahead and take the fuel composition of the gas, get the BTU value of the gas, and run this method and come up with an estimated exhaust flow. Well, what EPA realized is in doing that, effectively you were using an estimated or a calculated number to calculate another parameter. And so they came back with the FAQ section, addressed this and said, okay, no more manufacturer specs and no more mass fuel meters for an entire station. It's got to be a dedicated fuel meter. That fuel meter needs to be calibrated, and you can do a pre-calibration or post-calibration. The general practice here is that the requirements for a dedicated fuel meter calibration practices will go back to whatever your company's policy is on calibrating those fuel meters. So if it's once a quarter, hey, we want to see last quarter's calibration for that fuel meter. If you do it twice a year, let's see the last one that you've done on this. There is an option we've used insertable fuel meters on the day of testing to where we can tap into the fuel line and get those fuel meter readings directly there. If you're using an insertion type fuel meter, you need to provide a calibration at the end of the day for that fuel meter to show that it was accurately reading. Another way to get those estimated fuel rates is here at the engine panel. You do not want to use those brake specific fuel consumption numbers. There are I think some new panels that will give you that fuel meter reading that is actually tied to a dedicated fuel meter. Make sure that if you're getting a brake specific fuel consumption number off of an engine operating panel, that it does come from a directly associated fuel meter for that engine or for that source. Otherwise, that number that you're seeing in there is simply a calculated number, and it's no different than using a manufacturer's spec sheet or a program. I know Caterpillar has a GURP program where you can calculate your on-site horsepower and estimate your brake specific fuel consumption. Again, that does not fly, it does not meet the method criteria. You're gonna want to have a directly associated fuel meter for that source. Your other option, again, for coming up with exhaust flow is to measure it directly. And so two methods, essentially, method 2, and there's variations of method 2, like method 2C. For the purposes of engine testing, these are the two methods you would use. Method 2 for stacks that are typically larger than 12 inches in stack diameter. Method 2C is for your small diameter stacks less than 12 inches. And the two different types of pitos that you would use, The top one here is for large stacks. That is a what's known as an S-type pitot. The pitot at the bottom is a standard type pitot used for the smaller diameter stacks. And we'll go, I've got, this mock stack behind me, and we'll show some examples here shortly. Common on-site issues that we see as a testing company, as far as accessing the stack or getting to the stack ports, we've seen several non-OSHA compliant ladders to get you on top of the cooler. Once you get on top of the cooler, poorly designed catwalks or no guardrails to protect you. A lot of times the catwalks, in most cases, they are designed only to get you access to the catalyst housing, but you will not be able to access the end of the stack or the test ports on the stack. And there's still a lot of stacks that are out there that simply don't have test ports. And so this note at the bottom of this screen, this comes directly from EPA reference method 1. It's on the first page of that method about halfway down, and it says the requirements of this method must be considered before construction of a new facility from which emissions are to be measured. Failure to do so may require subsequent alterations to the stack or deviation from the standard procedure. Cases involving variance are subject to the approval by the administrator. So here's a couple of pictures of some stack setups. The one on the left, this one has a flat cut top, and I'll explain why that's important in a minute. The port is positioned. It's hard to see, but there is a port kind of sticking off of the left side of that stack, and then there's another one that you cannot see. It is positioned to meet the flow disturbance criteria. However, this stack is immediately on top of the muffler and the catalyst housing. Makes it very difficult to access. You can see that there's a caged ladder. You can see that there's railing for a catwalk to get over to that exhaust, but you cannot reach the test. So you would have to have a man lift to get up and perform these methods. And again, even if if this engine had a fuel meter on it, dedicated fuel meter, and you're saying you're going to use method 19 to calculate your exhaust flow, that's great, but you still have work to do at the stack, and it goes back to that waiver of stratification being revoked. You now have to get up there and do your stratification test. Quad J has some language to get around that using the 3-point long line, but there's some debate there on what really flies and what doesn't fly. So again, things to consider before you get out onto location. How are you really going to get the work done at the stack? An extension pole raising up a hook to throw over the top of the stack really doesn't meet the criteria any longer. So be aware of that as you approach your stack testing services. The picture on the right here, this is a dual stack engine that has an angle cut top. It does not have test ports, and it does not meet flow disturbance criteria. I actually tested this engine while TCEQ was on location, and I think that that TCEQ auditor emissions evaluator is actually on the webinar currently. So I did not know that he would be on here, but glad to know that I'm using this example and going to speak truthfully to it. We had to use some variances here to test this stack, and by going over the top with some probes designed to sample from the best location that we could get out of this stack, and to do our to get our pitot measurements at traverse points that would meet the method criteria. Again, we had to modify on the fly, but the variances that we used were approved. TCEQ came back and recommended that the operator modify their stack to be designed differently to overcome not only the not having test ports and not meeting flow criteria, but also in how you would approach testing dual stack units. And so we have since tested this unit again, and we're able to modify our procedures in the field to meet the requirements that were recommended. So again, there are ways to overcome this. It's just, you've got to know how to be equipped and what's allowed in the variances. But again, ultimately, at the end of the day, you can apply these variances in the field and still meet the data quality objectives of the methods, but you're still going to come under the authority of the administrator of that testing program, be it the state agencies under a state implementation plan or the EPA. They have ultimate approval of the variances to these methods. Okay, new pictures here. The one on the left, again, it has an angled cut top. It does have test ports to meet flow disturbance criteria. However, when a lot of the installers of these test ports or engine packagers or exhaust packagers, you know, they'll have these exhausts fabricated before they go up into the air, right? And so when they put in these test port plugs, they will run them in tight. When they do that, they're not thinking about these engines running and the exhaust getting very hot. And so a lot of times the threads, these port plugs get seized in the stack. And, you know, you can get up there with a large wrench, pipe wrench with a cheater bar, and you can bang on it with a hammer to try to loosen it. We have impact wrenches that we go up with. And on this engine in particular, we were not able to get the ports out of the stack so that we could sample from that port location. So again, we had to go over the top of the stack, some tubing to where we could get in the areas where we did not have or where we met the flow disturbance criteria and got our pitot readings over the top as well. The picture on the right is a good example. You've got two ports 90 degrees from each other so that you can intersect in the middle of the stack, hitting all of your traverse points. The one thing that we noticed here is this stack was designed to use a standard pitot as well as the larger pitot assembly. But per the method, that smaller port for your standard pitot is in the wrong place. They actually should have extended the stack a little bit longer and had that standard pitot port above. We were able to actually use the larger ports. They met the criteria. It was a little bit larger than a 12-inch diameter stack on this location. So we just used method 2 for this scenario. So getting to probe selection, again, the pictures here, we've got the top probe is what's referred to as a method 2 probe assembly. There are 3 components here. You've got an S-type pitot on there, you've got a sampling probe, and you've got a temperature probe. And I'll show this, one of these to you guys here in just a minute. The middle probe is a standard pitot, and then the bottom probe is a manufactured tubing. We can put these together in the field to meet the criteria if we don't have probes or test ports to get our probes into. So again, you're looking at variances here, but again, you can meet the data quality objectives of the methods. Okay, so what is a 3-point long line, and when can it be used? How do you use it? A 3-point long line, you can see the top picture is a close-up picture of the probe down at the bottom there. You've got 3 holes that would be spaced for a specific stack diameter at 16.7%, 50%, and 83.3% of stack diameter. You can use these probes according to Quad J regulations when the stack is greater than 6 inches but less than 12 inches. You can use a 3-point long line. If you are greater than 12 inches in stack diameter and you meet the half stack and 2 stack flow disturbance criteria, you can use a 3-point long line. Gets a little tricky here because that language only applies to Quad J regulations, and I think it applies to Quad Z as well. But when you get down to state regulations, going back to, for example, TA 117 or Chapter 106, this language is not in there. So when you've got that applicability, and we know that engines can be both applicable to state regulations and federal Quad J or Quad Z requirements. So you want to make sure that you're meeting both sets of regulations. So we think that if you want to use a 3-point long line, you really need to ensure that the stack is not stratified. And this goes back to method 7E, section 812, where you would sample at those 3 points before just saying, okay, I'm good to use a 3-point long line. So for every test that we do, we actually go and measure at those 3 different points to ensure that that we're not greater than that 5% from the mean stratified, or certainly beyond the 10% criteria from the mean. So you want to make sure that you can say, hey, I've met the criteria to use a 3-point long line, or a rake probe, as it's sometimes called. If you don't have a test port and you are intending to use a 3-point long line or a rake probe, you can go over the top, as you can see here on the left. Again, you would want to have a rake probe that is professionally designed. The holes on the rake probe are different sizes to accommodate the flow criteria for these, and so they're to certify these probes to show that you've got uniform flow through each of those holes on a 3-point long line. So all that to say, if you see someone that pulls a piece of stainless steel tubing in the field and drills 3 holes in it quickly, pinches one end of it and ties it into other tubing and throws it over the stack, I would question whether or not that meets the criteria. The probes that we have were designed by MEI and then sent to Olson Analytical to be certified for the flow criteria. You can certify these if you've got all of your the dry and wet meters to do this process. I don't think that your average gas compression testing company is capable of handling this certification in-house. So be aware of that, what type of probe you're using and what scenario you're using these probes. Okay, so I've got these pictures over the next 2 slides. They're in the presentation. They'll be available, but for right now, I'd like to stop sharing my my screen here, and we'll move to this my nice little mock stack here. So and show you some probes briefly. So again, this is the 3-point long line, and if you go back to the slides, you'll be able to see this better. But you've got 3 holes, and the hole at the end of the probe is larger to accommodate being able to get uniform flow as you're pulling the sample from this side. Again, there are scenarios in which specific scenarios in which you can use a rake probe, and how you use it, how you configure it. You want to make sure that you've got that criteria met specifically. So going back to alternate method 061, single point stack testing, the way that was typically handled was by throwing what is called a shepherd's hook over the top of the stack, sampling from the centroid area of the stack. Centroid area is defined as 10% of the center of the stack. And so this was the most commonly used way to sample on engine, or for engine testing. And in 2014, again, the EPA revoked the allowance for this type of testing. So if you see shepherd's hooks like this being used in the field, question that procedure, and make sure that if it is used, okay, how did you overcome the data quality objectives and meeting the criteria of the methods? Another thing that we commonly see, and it may be sort of difficult here, but right here is what's referred to as a drop-down tubing. And so a lot of operators will put these on their stacks. A lot of compressor rental companies will have these tied into the stacks. And they use these for the purposes of doing their periodic testing, their periodic or quarterly testing, using portable analyzers. And these tubings, the stainless steel drop line cannot be used for state level or EPA testing. And the reason is the methods would tell us that we need to transport the sample from the stack into our analyzers above the dew point of moisture. What happens when the lines are unheated, when you try to tap into stainless steel tubing like this, moisture condenses within the stack, and once you've got those moisture droplets in there, it starts to strip out your NO2. If you're using an FTIR analyzer and you tap into a drop-down line like this, you can absolutely see when that moisture droplet hits the gas cell within the FTIR. You lose complete signal. None of your analytes are going to register at that point. You'll see a massive spike in moisture. And if you do happen to get a reading, you can look at your NO2 and you can see that it completely drops out of the sample. So again, in order to have a full representation of what's in the stack, EPA and state level stack testers cannot use this drop line. So again, a common misconception. They work fine all day long for your quarterly and your portable testing practices with portable analyzers. Okay, so now that leaves us with a couple of options here. You have ports on your stack and probes that can go into those. Again, a lot of times we'll find that these ports are seized tight. We cannot get them open. And so we will go over the stack with it. Again, I had that picture of the different probes and one that we manufactured, and you can do this with, as long as you've got extra stainless steel tubing on your testing lab, cutters and whatever you need to fabricate an assembly like this. Pretty simple. You just want to make sure that you build this, design it to where this part is long enough to get across the stack so that you can sample at your 3 points to ensure that you don't have any pollutant stratification. You would want to make sure that this part of the probe goes straight down far enough into the stack to overcome flow disturbance criteria. And then you ideally would have something that you can throw on the stack to support this assembly, because once you've got this attached to a heated sample line, you know, the only way that you can ensure that this is going to stay exactly where you position it is to have something here supporting it, supporting the weight of the heated sample line going down. So again, this is not preferred, but you can overcome an improperly designed stack if you know how to do it. And again, I just want to go back to, if you do this, you are still at the mercy of the administrator as far as approving these variances. Again, you really want to have your stacks designed the right way from the beginning. And so that leaves us with the last option, the most correct option, to where we can tie into the test port with this is a method 2 pitot assembly, similar to what I showed you in the slide. Here's a larger probe here where you've got your sample probe, you've got your S-type pitot with your impact and static sides, and then you've got a temperature probe right here. So when you're sampling, you want to get your temperature measurements here at the sampling location. A lot of stacks, or sorry, a lot of engines are configured to where you'll get the exhaust temps right behind or right downstream, just downstream of your catalyst beds. Your stack temperature is much hotter there than it is at the sampling point. If you use that higher temperature, it will skew your results lower, so you're not reporting all of your results, or they're being skewed low. So make sure that you are actually getting your stack temperatures here at the sampling point location. So in order to do this properly, you mark your probe for the appropriate stack diameter. You go in. These can slide in. You can sample here across all of your points, your traverse points, getting your flow measurements. You can also sample here for concentration at your 3 points for your stratification check. And then once you're done here, you'll need to move the probe over and get into the other or into the other port, sorry, and get your measurements on the other line going through the center of the stack, and get all of your pitot readings to get your exhaust flow. So as you can imagine, if you're doing this procedure, it takes a little time at the stack to get all of these readings. We use digital manometers getting from the digital manometer to a fluid or an oil gauge based manometer at the end of the day. We get readings once per test run, and there's a question right now. I'm working with the EPA trying to get some clarity. I've got some correspondence on the new rules that are going into effect next month. I hope to follow up this presentation with additional clarity on that, but we'll get into that in just a few minutes. But again, and we can come back to this after the presentation. If anyone has any questions, I'm happy to show the stack again and move on. Or we'll keep going through the rest of the presentation. So let's see here. How are we doing on time? Okay, getting a little long here. All right, moving on from stack requirements, let's talk about the ASTM D6348 method. This is the preferred method when using an FTIR analyzer for quad J, quad Z testing. Most testing firms have moved into the FTIR technology and using this method. Well, quad J regulations read a little bit funny, and I've highlighted it down at the bottom of this screen. It says, and for ASTM D6348, report results of all QA/QC procedures in Annexes 1 through 7. Here's the issue. ASTM D6348 has 8 annexes. That 8th annex is a post-test quality assurance quality control procedure. It's intended to spot check your concentrations returned by your software, your data acquisition software that has the analytical algorithms that are all part of your FTIR usage. It proves that your test data meets its quality objectives and that you don't have any interferences at play here. So per test run, you select 2 FTIR spectra, so essentially 2 samples per run, 1 minute per sample over the course of a 60-minute run or 30-minute run for a PBR test in Texas, or if you're going to use this on a turbine under a quad K, you have to select 2 samples. You get 1 sample that is close to the average of that test run, and then you find 1 sample where you've got an outlier. So you do this for every analyte that you're looking at, and additional analytes as well. So your NO, your NO2 that make up NOx, your CO, you'll look at methane, ethane, propane, butane, anything that's going to have any influence on the total emissions reported, and your manual analysis of these spectral files needs to be within plus or minus 20% of what the algorithm values measured. You know, so for example, if you're on an engine and your FTIR and your data acquisition software is saying, hey, we're seeing 20 ppm of NOx. Okay, after the test is done, you have to go in and do this manual analysis where you're actually looking at the spectral residual or the spectral file of that point in time that you sampled, and you're looking at it on the wave spectrum, and you'll go through and again make adjustments to mitigate any interferences. And at the end of that, and you know, different analyzers, different programs have a different way of doing this. But at the end of that, you know, for this example, you would want to be at the low end, 16 ppm for your manual analysis, or at the high end, 24 ppm. Again, plus or minus 20% of what the analyzer said it saw on the day of testing. If you are outside of that 20%, it doesn't completely invalidate the test run, but you may have to go back and adjust the algorithm and do some other things to reanalyze this data. The point is, you have to do this Annex 8 portion. Our company uses MKS Multigas 2030s. This is the standard analyzer for measuring and using this method on engine testing. There are other companies out there that have FTIR analyzers. I know GasMed is one. Forgive me for not knowing some of the others, but I think most of these analyzers in their data acquisition software, they can run simultaneously while testing what's called an automated validation utility, an AVU. And that AVU, while you're testing, will say, we're collecting good data, we're collecting good data, we're meeting all of the requirements. A misconception here is that still does not take the place of Annex 8 and doing that manual analysis. I've had some conversations with the good people at MKS, and they will tell you that no, that AVU, that utility is not there to take the place of this manual analysis. So again, this is a conversation that you should have with your stack testing provider, making sure that they are going through this. EPA expressly states that Annexes 1 through 7 of this test method cannot be quantified without performing Annex 8. You report Annexes 1 through 7. On our test reports, we actually show screen captures of using the method analyzer within our software to show that Annex 8 is being done. Again, you can have two sets of regulations governing one engine test. So you may be trying to satisfy Quad J criteria, and then again, in the state of Texas, you might be testing against Chapter 117 regulations. Well, Chapter 117, if you get into the methods that can be used, they say that you can use the ASTM D48 method, but it specifically says Annexes 1 through 8 must be reported. We are on the rewrite committee for the ASTM method. We were hoping that a new version would have been introduced by the end of this year. Looks like it's going to be delayed a little bit, but we were asked to join the committee as a stack testing professional, and the intent of the rewrite is to ensure that Annex 8 is being performed. So again, you want to make sure that your data is being validated properly post the field work. So lastly here, two updates in the Federal Register that go into effect December 7th of this year. One is for EPA reference method 2 for exhaust flow. Table 2 of Subpart Quad J has some text added to clarify that when the stat gas flow rate measurements are necessary. So if you're gonna measure your exhaust flow, they need to be made at the same time as pollutant concentration. Again, I'm still trying to get clarity from the EPA on this. They're saying that it doesn't have to be sampled necessarily at the same stack. They're just saying it has to be done at the same time, and so I have some difficulty in understanding the full desire there, because again, if you're doing your method 2 traverse for exhaust flow, and you move the probe throughout the stack, getting your pitot readings, switch over for each test port, you get those pitot readings, and then you reposition your probe for pollutant concentration sampling. And so, again, I don't know how strict they're going to be on that simultaneous at the same time as pollutant concentration. As soon as I get clarity, again, I will get this out to everyone that's a part of this webinar. Lastly, EPA reference method 7E. 7E is for NOx. What you need to know about method 7E is that it also applies to method 3A for oxygen, method 6 for sulfur dioxide, method 10 for CO. So if you get into all of those methods for these other analytes, they will refer you back to method 7E for all of your calibration procedures. Well, method 7E has had language up until now, or until December 7th of this year, that says you can run the risk of holding off to do your post-run system bias check until the end of the test series, or the completion of an engine, or if you're doing multiple engines in one day, you can wait until the end of the day. You can risk doing that post-run bias check on your system, but if you fail it at the end of the day, it invalidates all runs up until your last system bias check. I can tell you that on compressor engines, even if you're using the ASTM method and FTIR, you still have to do this check for 3A for your oxygen readings. And we never fail these checks on oxygen at the end of the day. And in fact, we haven't had any issues. You can method 7E, method 10, they're not technology specific, so you can run your calibration procedures using an FTIR analyzer under these methods, and the stability of the FTIR analyzer, you're never going to you just don't fail these system bias checks at the end of the day. However, we now have to comply with this rule change that says you're going to do these checks after each run. So this is going to add time to your testing events. So just be prepared for that as an operator. Hopefully your stack testing providers are letting you know about this. It's going to require more consumables from our end, calibration gases. And so, we all know that everyone is looking for to meet budgetary concerns due to the oil and gas markets and due to the COVID environment. But this is a rule change that's just coming in at a bad time as far as additional time in the field and consumables being used. So that's it. Final thoughts. Mark Twain says it's never wrong to do the right thing. And C.S. Lewis, one of my favorite authors, says that integrity is doing the right thing even when no one is watching. That being said, it's easy to use some of these shortcuts in the field. It's easy to throw a hook over the top of the stack and just be lazy. A quality testing firm is going to try to train that out of their staff, and sadly, we heard a presenter at a conference earlier this year say, you might as well try to get away with it. The regulatory agencies don't pay attention closely enough to this, and I shook my head and said, no, that's not the approach that you want to take. At the end of the day, you want to be all I's dotted, all T's crossed. The states and the EPA have the ability to go back 5 years and review some of these test reports and find any issues with them. And I can tell you based on the activity that we've seen in the field from the state agencies coming out to witness testing, and the TCEQ earlier this year had an internal conference where they invited 3 or so stack testing firms to come in and present on methods to give them a better understanding on what they need to be looking for. They care about this. They are looking for the methods to be applied accurately and correctly, and they're taking the time to set up committees to address these issues, to ensure that there is consistency across all regions, across all states, to show that the playing field is being leveled, and they do care about these methods. We're all asked to conform to and follow these methods, and so we should, whether someone's looking or not looking. So that's it. If anyone has any questions, I'm happy to take them at this time. Either I hit a home run or I confused everyone.
Randy, have you turned on the chat? I believe there are questions available off to the right on the chat.
Okay, let's see here. Yeah, slides will be available. If a permanently installed traverse sample probe with drop tube is installed with tracing and insulation, will that probe be acceptable for? So, David, your question on the traverse sample probe. So, are you saying 3-point long line in that scenario has been installed, placed in the stack? Okay. You could try to get away with that. One thing you would want to be mindful of is the condition of that probe within the stack, whether it's been clogged. We see even the drop lines. There have been times where we've come in and been asked to tie into those because that's just where everyone samples from, and didn't get any exhaust measurements, and those lines were completely clogged. They had to be blown out with with nitrogen just to get them unclogged. And so you can imagine what a 1/4 inch or 3/8 inch diameter stainless steel tubing, if that's getting clogged, well then what's happening to those very small holes that are drilled into your 3-point long line? And again, David, I think there are some other considerations, stack diameter, and then any requirements to do, a 3-point stratification check on that engine. Again, as a general practice, we do a stratification check on every engine that we test. Sample filtration, we have a heated particulate filter that's inside of Austin. This is to answer your question about sample filtration. We have a heated filter that's inside the lab, so the sample comes down from the stack unfiltered all the way into the into the lab, and at that point it goes through filtration for potentially any particulates. Natural gas exhaust streams don't typically have a lot of particulate, and for a 3 hours of test run, 3 1 hour runs, or whatever the duration that you're going to be on a stack, you're typically not going to have that type of particulate buildup or contamination. Again, going back to your 3-point long line, if that's permanently installed in there and you're doing a test once a quarter or once a year, those little holes can get clogged over time. But over the course of a 5-hour test series, it's not a big concern to have it filtered here. Let's see here. Okay, more questions coming in. Does Ruben Herrera, does it matter if exhaust comes out of the sample port when the probes are inserted? No, I assume you're asking this in regards to is that considered a leak, as in like a leaking component or a valve? I assume that's the intent of the question. No, it does not matter, and the things that you would want to be mindful of, positioning to this port. I can tell you that as we're unscrewing these, pulling these out, you will feel a little bit of pressure that will push it right at the very end of it. But you've got plenty enough exhaust flow coming out of here to where it'll typically overcome that quickly, and all your exhaust is coming out here and no longer outside of that exhaust port. Okay, great.
This is a lot of great questions. We sure appreciate the questions from the webinar attendees. It's always great to see those questions and get that feedback. Randy, it's a fantastic presentation. I think we're about 8 minutes over where we were hoping, but that's great. I think we allowed about 8 to 10 minutes to start for people to continue arriving. So you're pretty much perfectly on time with 1 hour. Thank you very, very much. We also, I can announce now that we have the conference confirmed for April 7th, 8th, and 9th. I confirmed that with the hotel. Sorry, there's a truck pulled up outside my window. So April 7th, 8th, and 9th is the conference dates. We'll be posting that onto the webpage and including that in our follow-up emails. See, there looks like there may be one more question. Can you use an optical flow meter?
Yeah, and I was typing a response to James real fast. James, you could use an optical flow meter, but they're quite expensive, and they're also very large. So typically the test ports that you would see available on engines exhaust, they don't flange up like you would typically see for the optical flow meters, unless there's something out there that I don't know of. But those would need to be installed, per test, and so it may not be the most efficient way of doing this. Cost efficient. Again, the optical flow meters are quite expensive. Not to say that it can't be done. Typically, you would see that on larger, like industrial or power plant exhaust, where you're, trying to overcome traversing a 10-foot or 20-foot diameter stack.
One last question, Kevin Burbank. One of our stack testing providers stated that we were required to use an in-stack filter that was placed before the heated line. Is this true?
Kevin, I'd like to know where they're looking at, for that requirement, to see what are they trying to filter out. Again, natural gas exhaust burns pretty cleanly. You can put frit filters at the probe, but I have not, or I'm not aware of that being a requirement. You do want it filtered before you get it into your analyzer, specifically for an FTIR analyzer, where you're going into a gas cell with a laser beam passing between two mirrors. Anytime you get any particulate matter or dust in there, you have the opportunity to contaminate your your gas cell and basically eliminate the analyzer or the laser's ability to process.
Okay, thank you very much, and thank you for everyone attending today. We sure appreciate the great turnout for our very first webinar, and look forward to seeing you all in subsequent webinars over the coming 4 months leading up to the conference. And the registration will be open for the conference within a week or so, now that we have the date locked in. And thank you, Randy. Amazing content, great content, exactly what we love to see at the 4C conference. Very informative, very, very instructive, and there was great collaboration with lots of questions. So thank you very much, and thank you to all of the webinar attendees.
Thanks, Steve. Glad to have the opportunity.
Yes, and this will be posted on YouTube, be posted on my personal LinkedIn page, and posted on the company webpage. Thank you all very much.
Thank you.
Thanks, Steve. Thanks, Ray.